with my introduction. So yes, I'm a PhD student, and this is my fourth year PhD. Fourth year, I'm a fourth year PhD student, and I had MSc in Environment Management actually from FRI Dehradun and BSc from University of Delhi. And because right now I'm a PMRF research scholar, so this is my responsibility to teach you and to clear the problems if you have any while solving the assignment that Anjali Pal ma'am has given you. Okay. So how we will proceed? So this will be we will start with MCQs. I do have a lot of MCQs, and we will try to solve it with the discussion. And your participation is highly valued because it may be, as I told you, my background is not that chemistry background. So you people may also help me, and sometime it may be that I'm wrong. You can also correct me. But yes, I have worked, and most of the time I will be correct, but in rare case you can correct me. Okay. uh, okay, so Anjali Pal ma'am has covered 5 lecture till now, acid, base, salt, and this part 1 to 5. But because all the formula, whatever we had of let's say pH or POH or any equilibrium constant, so it is based on the molarity. Okay, so what I thought that we will first start to understand what do you mean by this molarity and normality, because the concentration of any compound or the solution, if you know the concentration, then only you can calculate the pH or POH or equilibrium constant. So my first MCQ's question will be based on molarity and normality only. Then we will try to understand what do you mean by acid, what do you mean by base. Different classification, different theories has been given by different scientists, so we will try to understand who told what. And then we will go on to the formulas of pH, POH, and whatever assignment that has been assigned to you. I have very familiar or similar question to that. So if you can solve that question, whatever I'm giving you, so like you can solve within a minute or within a second the assignment question that has been given. And yes, this KAKB is equilibrium constant for acid and base. We will learn about this. And then we can also at the end of this class we will also be able to calculate the pH of any kind of salt as well. Okay. So like this is very basic introduction of the molarity. As you people already know, this is I think ninth or 10th class syllabus, but let me revise it. That molarity is the total number of moles of solute. Just keep in mind, this is solute divided by uh, given the volume of your solution, and that volume of solution will be in the liters. So, and you can represent is by letter M, that should be capital M, and the unit will be mole per liter. Okay. So here n is equal to number of moles and divided by the volume of the solution, and this n is the mole of the solute. The another thing is, if you want to like if you are adding if you are changing your volume, then you can also calculate the molarity of your changed volume solution, and this is by m1v1 is equal to m2v1. This is very basic, we already know about this. This is, I think, again, ninth or 10th class syllabus, right? So my first question is, molarity is measured in what SI unit? So you can write in the chat box. You can you can communicate with me orally as well. Okay, Ipshmita told me this is mole per liter. Anyone else? So what is the unit of molarity? In the last only here. From here, you can guess. Angela, yes, small per liter. Ayush, yes, small per liter. So I think you are clear. So Hani is also giving me the right answer. Everyone is, this is very basic, and everyone is giving me the right answer. That is mole per liter, right? Okay, the next question is, we have a solution, and this solution was prepared using 20 gram of sodium hydroxide. So you have the mass of sodium hydroxide is 20 gram, and you need to calculate the molarity of this solution if the volume of the solution is 125 ml. You can take the time, because I think you need calculator, or you need pen or pencil as well. So you can take time, but you can calculate it very easily. So we have the mass, and we have the volume, but what the volume is in ml, you have to convert into liter. And you must know the molar mass as well, molar mass of the sodium hydroxide, because the formula will be given mass upon molar mass. So this is the number of moles, okay, and number of moles divided by the volume of the solution. So volume of the solution will be 125 divided by 1000, because we are changing it from ml to liter. Ayush calculated it so fast, and he said that it is 4 molarity. Anyone can also try this. Okay, first you can you tell me the molar mass of sodium hydroxide? So sodium hydroxide is NaOH, and NaO, Na. So what is the molar mass of Na? And then O plus H. Then this will be equal to 40. Yes, I use this is 40. Then just calculate the number of moles first. That is given mass upon molar mass. This is 20 by 40, and then divide by the volume of the solution, and this we have to convert first into ml to liter. So is everyone able to calculate this? If I'm fast, then you can tell me, you can interrupt me anytime. So yes, this is uh, 4 molar, the molarity is 4. And yes, the volume is 125. We calculated it into liter. Then molar mass is 40, and number of moles is equal to 20 by 40, that is given mass upon molar mass, and molarity is the number of moles upon volume. And this is how you will get the molarity for. Is there any doubt? If you have any doubt, then I can solve, otherwise we can go further, right? Okay, this is again very simple question. So we have 20 ml of 2.56 molar carbon tetrachloride solution. So here we have molarity, but we need 1.28 molarity solution. Then how many ml of 1.28 molar solution can we prepare? So here what we are doing, we are changing our molarity from 2.56 to 1.28. So for that, we also have to change the volume, right? And we have the formula, that is m1v1 is equal to m2v2. So can you calculate new volume? For that volume, the molarity will be 1.28. Is anybody calculating this? We just need to have the volume of the new solution, and that new solution have the new molarity. So M1 V1 is equal to M2 V will M2 V2 will work. Is anybody trying to speak? Can you calculate this? Okay. So I think no one is replying, so I should reply by myself. So the answer will be 50 ml, and how this will be 50 ml. So we do know that M1 V1 is equal to M2 V2, and we have two molarity, that is 2.56 and 1.28. We have another volume, that is 25 ml. So we have to convert this into liter, and then we will get the 50 ml. So if you have 50 ml of new solution, that will give you the molarity of 1.28. Okay, this is again very simple question. A solution with the concentration of 7 moles per liter is denoted as. Okay, Angela is okay, yes, and then someone gave me, Angela gave me 7 m. Okay, anybody else? You can write in the chat box. You can also speak your answer. So yes, because we know that moles per liter, this is nothing but molarity, and molarity we can denote by the capital M. So yes, the answer B should be right, and this will be 7 m. This is this is again the question only from the same formula, and this is, we have the volume of the solution, that is 25 ml. We have the molarity of the solution, that is 2.2 molarity of NaOH, and you just need to calculate how many moles of NaOH were involved in the reaction. And we know that the number of moles divided by volume will give you the molarity. Number of moles divided by the volume of the solution. What happened? This is very simple question. Angela gave me answer 5 moles. Angela, have you changed this into liter first? Okay, so change into liter, because the unit of your molarity is number of moles per liter. So first change it into liter. So this will be 25 upon 1000. So what you just need to do is multiply this 0.2 with 25 upon 1000. because the number of moles is equal to molarity multiplied by the volume of the solution. So what will be the answer? This should be 8 moles. And how this will be 8 moles? Because um oh, number of moles we are no, we just need to change this, because number of moles divided by 0.25 liter is equal to 2.5. And if we will do this, then this should be multiplied by this one. And what answer should we get? Hmm? Just tell me. 50 and then 2, 3 is this one. So here the answer should be yes. So let it be correct. 5 moles. Sorry for the MCQs that I have given you, but the answer should be 0.005 moles. Okay. I think this is clear, right? Uh, this is nothing but just we have number of moles is equal to, we have to multiply this molarity with the volume. Okay, and then this is how we can get the answer. Okay, the next question is this is trickier question, a little trickier question, because you have the solution that is CaCl2, and of which you have given the molarity that is 2, and the solution volume is 25 ml, but you need to calculate the moles of chloride ions, but not the moles of CaCl2. So can you calculate the moles of chloride ions? The only tricky thing is that whenever you will calculate the molarity of CaCO3, whatever the molarity of CaCO2 you have to multiply it with the 2. Why 2? Because each molecule, this CaCO2, is giving you the 2 molecules of the chloride ions. Right, so you have to multiply it with the 2 so that you will get the number of moles of the chloride ions. So now can you calculate it? Dipanjan Das given me the answer 0.001. Okay. Ayush gave me 0.1. Just keep in mind, first calculate the molarity of CaCO2. Then we know that CaCO2 will give you 2Cl2, 2Cl, and then that's why we have to multiply it with the 2. Okay, so the answer is 0.1 mole. And this is how we can calculate. So first we have to calculate the moles of CaCl2, and that will be molarity into V, and that will give you the 0.05 moles. But you know that each mole of CaCl2 will produce 2 moles of the chloride ion, right? And that's why whatever the molarity you have to multiply it with the 2, and that will give you the 0.1 mole ions. So I think this is clear, is it? Should we go further? Okay. Next question is again very much easier. That 50 gram of KCl is dissolved in water to make a 4-liter solution. Then what is the molarity of the solution? We have 2 or 3 questions more based on molarity, then we will proceed to the pH, because we know that pH is based on the concentration only, and molarity is giving you the concentration. So you have the mass of KCl and you have the volume of the solution, that is 4 liter, and the molar mass is also given of KCl, that is 74.5. And now you need to calculate the molarity, and molarity will be given mass upon molar mass upon the volume of the solution. Can you calculate it? So you have given mass, you have molar mass, you have the volume of the solution. You just need to calculate the molarity. Okay, Andrela gave me answer first, that is 0.167. Okay, so the answer will be first only, that is 0.167. And how it will be, what you need to do, given mass upon molar mass, so 50 upon 74.5, and divide by the volume of the solution, and volume of the solution is 4. So this is how you will have the answer, that is 0.167. Because this is important question, because you should know the molarity of the sodium chloride, and that because sodium chloride is very prevalent in the seawater. So, seawater have approximately 28 gram of NaCl per liter. So, what is the molarity of sodium chloride in seawater? Can anybody tell me the molar mass of NaCl? What is the molar mass of NaCl? So if you know the molar mass of NaCl, then what just you need to do is 28 upon molar mass of NaCl, and you have 1 liter, then upon 1, and that's how you will get the answer. What is the molar mass of NaCl? Okay, Ipshmita gave me answer, that is 58.44 gram per mole. Okay, this is the molar mass, right? Okay, so you are right that molar mass is 58.443, or let's say 44, and then we just need to divide the given mass, that is 28 upon molar mass, and this is how you will have the value of uh, molarity, and this molarity will be 0.7. Okay, I think right now uh, I think you can calculate it very easily. Molarity of 15 ml to molarity aqueous solution when 285 M1V1 is equal to M2V2. But you just have to keep in mind that the new volume will be 285 plus 15, because you are adding water into that. So your new volume will be 300, right? 285 plus 15. So your new volume will be 30, and you just need to calculate the molarity. So your M1 is 2, your V1 is 15, M2 you have to calculate, and V2 is 15 plus 285, that is 300. So now can you calculate the molarity when you have added the water of 285 ml? Ayush gave me answer zero point 0.1. Okay. Okay, so yes, the answer is zero point 0.1 molarity only. And how we are doing this? We know that M1 V1 is equal to M2 V2. And because we are adding water into the solution to get a new solution, right? So here V2 is equal to 300. And whenever we are calculating M2, that is the molarity of the new solution, it will be 2 upon 15 upon 2 into 15 upon 300, and that will give you the zero point 0.1 molarity, right? Okay, this is a very nice question that I got. And this is, which of the following concentration determine technique gave a more accurate value? Molarity, molality, formality, and normality. Up to now, we just studied the molarity, but yes, you can give me the answer of this. I'm expecting the right answer from Ayush because like he's from chemistry only. Ayush gave me molality. Okay. Ipshmita, what do you think? Andrila? Ayush, can you tell me why this is giving you the more accurate value? Andrila, no. The answer is different. Answer will be molality only. And can you tell me why? Ayush, do you want to speak? Obviously. So he told me that no factor is dependent on the temperature. This is right. And why? Because the formula that you have of the molarity or normality or formality, that formula has the volume. And you know that volume is changing with the temperature. Right. So if we are increasing or decreasing the temperature, then volume can also change. And because of that volume, the concentration can also be varying. Okay. So, but molality, if you know the formula of molality, at the denominator, we have the weight, right? And this is not the volume. So that's why this is not dependent on the volume. This is not dependent on the temperature. So the more accurate value given technology, the technique is molality, right? Is it clear? So molality give the more accurate reading since it is a temperature independent term. And another hand, all terms are temperature dependent, right? Okay, let's come to the normality. I have just one question of the normality and then we will go to the pH. So you know that normality is nothing but the number of equivalent gram per volume of the solution in liters. And you can also say like weight of the solute upon equivalent weight of the solute multiply by the volume of the solution. And if you know that the number of equivalent gram equivalent, then here like from the first line only, but the weight of solute upon equivalent weight of solute, right? And if you have, you also have the relation of normality with the molarity, and this is nothing but the normality is equal to molarity multiply by either basicity or acidity. Okay, and based on that, I have one question. The normality of 0.98%, that is weight by volume H2SO4 solution is. So it is just saying like you have 0.98 gram of H2SO4 in 100 ml of solution, right? Because it is 0.98% weight by volume. So the volume is, let's say, 100 ml, sorry, 100 and 100 liter, and then this is giving you 0.98 gram. So can you calculate the normality of this? I should from here. Okay, here the answer is zero point 0.2 normality, and how it is, because we do know that we have 0.98 gram of H2SO4 are dissolved in 100 ml of solution. And then whenever we will convert into number of moles, then we know that this is mass by molar mass, and the molar mass of H2SO4 is 98. So the number of moles will be 0.01 moles. But you know, then the molarity of H2SO4 will be zero point 0.1, because you are dividing it with the volume in liter, and that will be zero point 0.1. But if you are calculating the normality, then you have to multiply this molarity with the number of equivalent per moles, and this is 2, because this is giving you the 2 equivalent of H plus ions per mole. Okay, so just you need to do is you have to multiply your molarity with the number of equivalents per mole, and these are 2, so that's why the answer will be 0.2 normality. If I'm fast, you can interrupt me anytime, otherwise I will go on. Okay, let me skip this because a lot of questions has been done based on this. Okay, so the next topic was to identify the acid and base. Uh, yes, this question is very nice. Which of the following is the strong acid? So we have HCl, we have CS3COH, we have lemon juice, and we have pure milk. So which of the following is a strong acid? And I will tell you why, but you just need to tell me first, like which compound you think that this is the strong acid. You may be confused among, I don't think that pure milk is the strongest acid, and among these three, HCl, acetic acid, and lemon juice, Ayush told me like it is HCl. Okay, Suvarna also gave me HCl, Andrela HCl. Yes, so the answer is HCl only. So can you tell me the pH of HCl? What is the pH of HCl? What is the pH of acetic acid? What is the pH of lemon juice and the pure milk? And what made this HCl a strong acid? The acidity of any compound is based on how much dissociation is happening. Okay, so HCl is giving you the 100% dissociation in the water, and that's why it's a very strong. Okay, Ayush gave me the pH between 2 to 2.5. Okay, there was I think I took this question from Baizu only, and here they told me like the pH of HCl is near to 1, and acetic acid this is near to 5, lemon juice 2.2. I have just some doubt on this 2.2 anyway, and pure milk has the pH 6. And if you know, please read first line of your of my slide. That is the strong acid completely dissociate into its ions in an aqueous solution. Okay, so for example, if it is the HCl, then it will be dissociate between H plus and Cl minus. Okay, and that's why this is making this a very strong acid. But if you will take the case of acetic acid, then this is the weak acid because it only partially dissociate in water. Okay, and lemon juice, this is a weak organic acid, and here it doesn't completely dissociate in water, and so this is not again a strong acid. And pure milk, you know that it is near to neutral and not very acidic. Okay, so answer should be HCl. Which of the following is a neutral salt? Okay, so first let me tell you about this salt. So most of the time salts are made up of like acid and base, because we know that the reaction between acid and base will give you the salt. But it may be that there may be four combination of formation of this strong acid, strong base. This may be the first combination. The second combination will be the strong base and weak acid. The third combination will be the reverse of this, that is the strong base and the weak acid. And the fourth combination may be weak acid and weak base. Okay, and based on that combination, the salt may be neutral in nature, salt may be acidic in nature, and salt may be basic in nature. Now, out of these four salt, you have to tell me which salt is neutral in nature. So like in back of your mind, you just have to think what was the acid, what was the base, the combination of this acid and base formed the salt. So this should be, if it is a neutral, neutral means what? The strong acid and strong base, that combination only will give you the neutral salt, otherwise it will not give you the neutral salt. So you have to just find out one salt in which the acid was also strong and the base was also strong. Ayush gave me answer B, that is CH3CONH4. Okay. Don't you think, Ayush, that this is formed by acetic acid and ammonia, and this acetic acid is not that much strong acid? And we need the combination in such a way that there should be strong acid and strong base, that only give you the neutral salt. Subarna gave me answer first, that is NH4Cl. Ipsmita also gave me NH4Cl. Yes. So are you thinking like we had the ammonia, that is NH3, very strong base, and HCl, that was the very strong acid, and that combined and gave you the neutral salt. Anyway, so what should be the answer? What should be the answer? Ayush only gave me the right answer. So neutral salt is like when strong base and strong acid react, and it may be the weak acid and weak base also. But like whenever it will be the basic salt, basic means you should have the strong base and weak acid, and for the acidic salt you should have strong acid plus weak base. Okay, and if we will go to NH4Cl, so NH3, this is ammonia, is a weak base actually, and HCl is a strong acid. So this will not give you the neutral salt. Then second, we will go to NH3COOH. This is weak acid, but NH3 is also the weak base. Okay, so this may give you the neutral salt. Then CH3CO and Na. So the first is weak acid and the second is strong base. So this is again not giving you the neutral salt. And the fourth one is Na2CO3. So here we have the weak acid and the strong base. So this is also not giving you the neutral acid. So whatever the answer given by Ayush was right, because not only the strong acid, strong base, but weak acid, weak base can also give you the neutral salt. But there is a not that much neutral. You will not I will give you the formula, uh, how we can calculate the pH of every salt, right? Okay, now the question is, which salt is acidic in nature? So you just have to find out the combination in which acid was strongest and weak base. Ayush gave me NH4Cl. Okay, because like in last slide only, we got to know that this ammonia is a weak base, right? And HCl is the strong acid. Can you please mute? Who is speaking? Who's here? I should. Wait, anyway, uh, Althi, you raised your hand. Do you want to say something? Anyway, so yes, NH4Cl should be your right answer for the salt that is acidic in nature. And again, let's talk about this. NH4 is the weak base, HCl is the strong acid. Then this acetic acid is the weak acid, ammonia is a weak base, and then this NaCl is formed by NaOH and HCl, and out of which this NaOH is the strong base, HCl is also the strong acid, then that will give you the pH of 7. And the last one is like H2CO3 is the weak acid, and NaOH is the strong base. Okay, so what are antacids? What are antacids? Are they salt? Are they acids? Are they buffer or the bases? Which one? Can you can you mute suddenly? Yes. Can you please mute yourself? Okay, someone told me like it is buffer. Anyone else?
Buffers.
This is not buffer actually. I will tell you how. Ayush told me it is a base. Okay, so what is the use of antacids? Actually, whenever we do have acidity in our stomach, so what we used to do, we used to take some like medicine or syrup, you know, and that syrup will what that syrup will do, that will react with the acid and will form the salt, and this is how your acidity will be neutralized. So right now, can you guess like what can be antacids? This will be base, right? So because base only when react with the acid will give you the salt, and this is how your acidity can be treated. So whatever the medicines you have for the acidity, these are mostly have the compounds that are basic in nature. Can you tell me the name of some antacids? Anyway, so antacids are the substance that neutralize excess stomach acid, and that is mostly HCl, to relieve your symptoms such as heartburn, indigestion, and acidity. And these are bases, and the example may be magnesium hydroxide, aluminum hydroxide, sodium bicarbonate, or calcium carbonate. So these are the bases, mild alkaline substances, and whenever these bases will react with the acid, then this is how you can neutralize the stomach acid. Okay, so antacids are base. Okay, so we talked about acid and base. We talked about which is the strong acid, which is the like acidic salt, which is the basic salt. But we have to understand first what do you mean by acid and base. So we do have some theories, and we will talk about here about the three theories only. The class covered like Anjali Pal ma'am covered five theories, but here I will only explain three theories, the Arrhenius, then Bronsted, Lori, and the Lewis. So, can you tell me about this picture? Like, what does it mean? Can you say something about this picture? This is the Venn diagram, and in Venn diagram, the big circle is for Lewis, the small circle is for Bronsted Lori, and the smaller circle is for the Arrhenius. So, can you tell me? So, what do you mean by this? Can anybody tell me about this? Why do we have the Venn diagram? And in that Venn diagram, the smaller is Arrhenius, then the bigger is Bronsted Lori, and the biggest one is Lewis. So the thing is, whatever the theory has been given by this Arrhenius, it was limited for a limited number of compounds. Okay, and this theory was limited to. I will tell you, there was some terms and conditions, and under that terms and condition, if that compound comes, then only it will be considered as acid or base. Otherwise, it will not. Like it didn't explain much about this. So you can say like there were a lot of terms and condition, based on that acid and base were selected. Then these terms and conditions were very lenient, given by this Bronsted Lowry, and then Lewis give you a very like list specific definitions of the acid and base. So
Hello,
let's
good
talk
evening,
about
madam.
it once. Yes.
Good evening, mom.
Okay. Okay,
After
if we are
shopping,
talking about this, can you please mute yourself? Hello. Okay, so if we know the definition that is given by Arrhenius of the acid and base, so there was two important things. The first is dissociation, and the second was water. So your solvent should be water, and the compound will be dissociate. Okay, and when your compound will be dissociate in water, if it is giving you the H plus ion, then this will be the acid, and if it is giving you the OH minus ion, then this will be the base. So this is how the definition was very limited. Why very limited? Because this theory is just based on the solvent. Like you should have the solvent, you should have the solution. But what if we do not have the solution as a solution made up of water? है ना? So this was very specific in nature, and it may be like it is not giving you H plus or OH minus ions in the solution. It may be possible. So but just keep in mind, Arrhenius had two conditions. The first condition is the compound should be dissociate, and second thing is that should be dissociate in the water solution. Okay, and if this will give you the H plus ion, then this is acid, and if it is OH minus, then this will be the base. And this had a lot of disadvantages, as I told you, and based on that, we needed to have new theories. And the one theory was the Bronsted Lowry theory, and here they told whenever the substance will donate a proton, okay, then this will be the acid, and if it will be the proton donor, then this means it is a base. Okay, was the definition of acid and base given by the Bronsted-Lowry. Then if we are consider this Lewis acid and base, in spite of proton acceptor or donor or receiver, they use the word electron pair acceptor and the electron pair donor. If it is the electron pair acceptor, then it will be the Lewis acid, and if it is a electron pair donor, then it will be the Lewis base. Okay, and he didn't mention about protons, he didn't mention about hydrogen. So a more compound can fit into this category. So that's why that Venn diagram is giving you the clue that this is more comprehensive definition that has been given by Lewis as comparison to the Arrhenius and the Bronsted-Lowry. This is how you can see your acid strength or basic strength with respect to your acidity. Uh, Ravi and some other boy raised the hand. Do you want to speak, Ravi? Anyway, so let's talk about the ion product of water. So what does it mean? Because water undergoes into self ionization, so this is known as auto ionization itself. So what will happen, this H2O will dissociate between H plus ion,
ఏమేమో పండిస్తాను.
H plus ion plus OH minus. Okay, and the equilibrium constant will be, you have the product that is H plus and OH minus. So the multiplication of the concentration of H plus and OH divide by the concentration of H2O. So this will give you the equilibrium constant. And because we know that the concentration of H2O is constant, because the molar concentration of water in pure liquid form is nearly constant, and that is 55.5 mol per liter. And because of that, if we are moving the concentration of H2O as a K, uh, uh, if we are moving this, multiplying this H2O with the K, then we will get the ion product of water, right? So what will be the ion product of water? This is Kw, and this Kw will be nothing but the concentration of H plus and OH minus. Okay, and here the concentration will be dependent on H plus and OH minus. Just keep in mind, because we have some question based on this one. So the ion product of water is Kw, and Kw is nothing but the concentration, and we already have studied about the concentration. Concentration is nothing but the molarity that we have studied till now. So if you have the molarity of H plus, if you have the molarity of OH minus, then you can tell the ion product of water. Then here we can see if we have any acid that is Ha. Okay, and if that Ha is dissociating between H plus and A minus. Okay, so H plus, this is proton, and A minus. And if we are multiplying the concentration of H plus and A minus, and if we are dividing it by Ha, that was the initial compound, initial acid, and that will give you the equilibrium constant for the dissociation of Ha. So this is equilibrium constant for acid. Okay, and as like in very initial stage only, I told you, whenever we have 100% ionization, or if we have more dissociation of that compound into the ions, that will give you higher acidity or higher basicity. So from here only you can tell, if the K value is more, K value is more means you have more ions as comparison to the that compound. So for example, you have more ion for H plus ion and A minus ions as comparison to the compound that you have, like the acid you had, that is the AHA. So based on that, if you have the value of Ka, then based on that Ka value, you can tell which is strong acid and which is weak acid. Based on that value, the Ka value should be larger uh, for a strong base, and Ka value should be smaller for the weak base. Okay, So if you have calculated this Ka, and if you are doing the negative logarithm of this constant, then this will give you pKa, that is the power of your equilibrium constant, and that will be equal to minus log of Ka. So this is how this formula will also used for next numerical question and the numerical question that ma'am has given you into the assignment. So just keep in mind, you have the equilibrium constant, and if you have acid, then that equilibrium constant will be the constant for the acid compound. And whenever you have the more value of this Ka, means the acid is stronger, because the dissociation because it dissociate almost completely in water. And if your K is small, then this means the acid is weak. uh, if we are talking about the base, then again, the base will also dissociate into the ions, and this will give you, for example, you have one base that was the B, and if you are having this into the solution H2O, then this will give you the BH plus and OH minus. And whenever you are multiplying the concentration of the product divide by the concentration of the reactant, then this will give you the equilibrium constant for the base. Okay, and if we are doing the logarithmic value for this Kb, then we will have the pKb, and this will be equal to minus log Kb. And here you can see the example of this. If you have the ammonia, and ammonia, if we are reacting it with the water, then this will give you the ammonium ion plus OH minus, and this is how Kb will equal to the concentration of NH4 plus, and the multiply by OH minus divide by the ammonia. This is how this will give you the base equilibrium constant. Okay, there is a relation between this Ka and Kb. So if you are multiplying this Ka with Kb, this will give you the Kw, and we have learned this Kw. Kw was nothing but the ion product of water,
Hi
right?
friends.
So this multiplication of Ka into Kb will give you the ion product of water, and we know the value of the ion product of water. What is the value for this? The Can you please mute yourself?
మేము ఎక్కడికి ఆట ఆపితే అదే మేము ఎక్కడికి ఆట ఆపితే అవి మొదలెట్టారు.
Can you mute? Can you mute yourself? Okay, so we already know the value of ion, this Kw. So here the ion product of water, that was the Kw, and we know the value of the Kw, and Kw value is nothing but 1 into 10 raised to power minus 14. So if we know the value of Ka, then we can tell about the value of Kb as well. Okay, so this is how we can exploit the relationship between Ka and Kb. This is the slide that I got from Anjali ma'am only, and this was nothing but if you are having any acid or base and you are dissolving that acid and base into the water, then water can decide like what will be the acidity and the basicity of that acid and base will have. So so for example, here it was like if you have the solvent like ammonia, which is stronger base than water, then weak acid like acetic acid will also appear as the strong acid like HCl. So this is nothing but the leveling effect of the water, and the same thing can happen with the acid as well. Sorry, for the base, and this is how this is the leveling effect of the water. Then okay, as I told you, we can calculate the pH of the salt. Okay, and in very initially we had one MCQ, and in that MCQ I told you if we have the salt of strong acid and the strong base, then this will give you the neutral salt. Okay, so neutral salt means pH of 7. Okay, but the second thing is, if we have salt of weak acid and strong base, then obviously it will give the pH, which will be the basic in nature, means more than 7. But how we can calculate the exact pH of that salt? It will be 1 by 2 pKw. We talked about kW, right? And the logarithm of kW will be the pKw. Then half pKa plus 1 by 2 log of C. So C is nothing but the concentration of the salt. Okay, so based on that formula, we can calculate the pH. But the condition should be that salt should have the weak acid and the strong base. But if the case is reverse, then the formula will be 1 by 2 pKw minus 1 by 2 pKb minus 1 by 2 log C. And if we have the weak acid and weak base, then obviously acid constant and the base constant will be considered into that, and then your pH will be 1 by 2 pKw plus 1 by 2 pKa minus 1 by 2 pKb. And the thing is, we should know from where this formula came. So I have a few derivations for this. So the first example was salt of strong acid and strong base, and you people know that if we have uh, for example, if it is a NaCl, then NaCl will completely dissociate in the water and will give you Na plus Cl, right? Because as I told you, if it will be the strong acid or strong base, dissociation will be near to complete, right? So, and likewise, if you have HCl, then HCl will give you H plus H plus ion plus Cl minus, and this is how everything will be neutralized because the ions will be combined to each other. Okay, and the dissociation was complete, so that's why this is giving you the pH is equal to 7. But if you have the weak acid and strong base, so here I have one example. um, if you have the salt and that salt is CH3COONA, and that salt formed from acetic acid and NaOH. Okay, so what will happen? First, the salt will be hydrolyzed, and uh, first you have the acetate ion. That acetate ion will be CH3CO minus. Okay, and if we will do the hydrolysis with the H2O, then this will give you the acetic acid plus OH minus. Okay, so what we will do, um, if uh, uh, if we have the strong base, then we will calculate the equilibrium constant for the base, right? So Kb is equal to the concentration, the product of the concentration of the reactant upon sorry, the concentration of the product, the multiplication of the concentration of the product upon the concentration of the reactant, right? And then if we are assuming here, like the concentration of OH minus is X, and here because it is in equilibrium, then
Washing person ఇక్కడ
CH3COH equilibrium will be also X. So this is how Kb is equal to
హలో ప్లీజ్
X
నమస్కారం
square upon C. है ना? And here x is equal to kb c and the under root of this kb and c. And if we are doing the logarithm of this POH, then this is how we can calculate this pH value. The pH, the formula that I gave you here, it was like log kb upon c. In spite of that, here it was log kb plus log and this log kb is nothing but pkb, right? And then log c, I show you. So here you can see. Okay, the second and third one. So this is how you can derive this formula. then this is the formula for weak base and strong acid. I think you can see my slide. The derivation is complete and you can explore this one, because I just want to go ahead to tell you about the solution of the assignments that have, but the solution of very similar question that has been given in the assignment, right? And this is how, if we have this weak base and weak acid, then also we can calculate the pH. And this is the derivation, how we got the formula, that formula that has been given into this slide. Okay, so just keep in mind three formulas, and based on that, if you have any salt and if that salt is acidic in nature, then you have third formula. If you have acidic in nature, then you have third formula. If that salt is basic in nature, then you have the second formula. If both acid and base were strong, then this will be like neutralization will be complete. This will give you the pH of 7. And if you had a very weak acid and base, then the formula is different. Okay, let me just remove this. Okay. The next thing is because the assignment question is based on pH also. So first I have to cover a little bit about pH and then the question. So what is the pH? pH is nothing. P means power of the hydrogen ion. So this will be nothing but the minus logarithm of the concentration of H plus ion. This is very simple. Okay, and if we are calculating, so here we have the example, you can explore it later. But if we have the pH, if we want to calculate the pOH, so pOH is nothing but this is the negative log of the concentration of OH minus. Okay, then what is the relationship between this pH and pOH? So if we will add pH and pOH, this will give you the value 14. Okay, and then we already have discussed about this pKa. So we have calculated the equilibrium constant for acid, that is Ka, and we also have calculated for the base, that was the Kb. And if we are doing the logarithm of this constant, then we will have the value pKa. Okay, and if we want to calculate Ka from pKa, then you have to anti-log it. And the same thing is for pKb, and we already have discussed this. Okay, let me tell you a little bit about this buffer solution as well. So what was that? So buffer solution is nothing but that have some mixture of either weak acid and its salt, or weak base and its salt. So what will happen whenever you will adding some acid or base into the that solution, it will resist the increasing the acidity or basicity of that solution. Okay, so this is the role of the buffer solution. And if we are here, if we want to calculate the pH, then pH will be pKa. Like if you have the weak acid and its salt buffer solution, then the formula will be pH is equal to pKa plus log of concentration of salt upon concentration of acid, and this is nothing but this is the Henderson equation. Same thing is for the base as well. So if you have base, then in place of pKa, you will have pKb plus log of the concentration of salt upon concentration of base, and that will give you the pOH. This is not right now very much required. Okay, from here, yes. So this question is very much similar to the question one, because only the value and the compound has been changed, but the terminology is very much similar to the assignment question one. And the question is, the solution is prepared by diluting 20 ml of 0.05 molar HNO3 to 500 ml. So what you are doing, you had first the solution of HNO3 and the solution volume was 25 ml, then you are diluting it with the water and you are making it to 500 ml. Okay, and now you need to know the pH of the final solution. So how you will do this? Can you guess how you can do this? So this is very clear that pH is nothing but the minus log of the concentration of H plus ion. So you have to calculate the concentration, and concentration is nothing but the molarity. So you have to calculate the molarity of H plus ion. You know? So how you will calculate this?
No.
And you know that the formula of molarity is what? So, firstly, you can start with M1 V1 is equal to M2 V2, because initially you had volume 25 and then you have volume 500 and your molarity will be changed. Okay, so your molarity will be from 0.05 to something else. So that molarity you will have for the HNO3, that is the nitric acid. But because you know that nitric acid will give you H plus ion concentration, this will be similar, you know, and that's how. So whatever the molarity, whatever the concentration of a new HNO3 you will have, that will give you the concentration of H plus ion, right? And then what will happen? Then you will do the minus log of the concentration of H plus ion, and that will give you the pH value. The ultimate goal is just to know the concentration of H plus ion and then do minus log of H plus ion, the concentration of H plus ion, that will give you the pH. But first you have to calculate the molarity of nitric acid, but when the volume is 500 ml. So can you calculate it? Anybody can tell me the answer of this? This question is very much similar to the first assignment question. Do you people have pen and paper with you? Because otherwise, like I should not wait much and I should go further. So can you calculate the pH? You just need to first calculate the molarity of the new solution when pH, when the volume is 500. Whenever you will calculate the molarity, that is the concentration of HNO3, from that concentration of HNO3, you will calculate the concentration of H plus ion. Then if you have concentration of H plus ion, then your work is almost done, because whenever you will do the minus log of the concentration of H plus ion, this will give you the pH. So let me tell you how we can do this. So in spite of this step 1 and step 2, you can just calculate using M1 and M1 V1 is equal to M2 V2, and you can calculate the V2. Here what they did is they first calculate the moles of HNO3 from the first solution, and that solution has the volume 25 ml. Okay, so mole was 0.00125 moles, and then based on that moles, and now the total volume is 0.5, because 500 ml is equal to 0.5 liter. And whenever we are multiplying the number of moles with the total volume that we have right now, then we will get the new concentration value. Okay, and because we know that nitric acid is a strong acid, and that will be completely dissociate into water, and that will give you the H plus ion and NO3 minus ions. Okay, and that's why whatever the concentration of HNO3 you will this will be equal to the H plus sign. So this will be 0.0025 molarity. And the pH is minus log of H plus sign. And this is how we will have the value of this pH is 2.6. Is there any doubt with this solution or with the question? Should we go further? Anyone? Are you understanding it? Are you able to understand what was the question and how the solution, how the pH of the final solution is 2.6? You can write in the textbooks if you are like understanding it. Is it clear? Is it clear how we calculate the pH of that solution? Okay, should we go further? If Smita, are you here?
Yes, ma'am.
Okay, Sonia. The next question is, okay, Rahul. So next question is, we have one solution that have the acetate and the acetic acid, and the pH of the solution is already given, that is 4.8, and we have to calculate the ratio of acetate to acetic acid. And the equilibrium constant of acetic acid is given, that is 1.8 into 10 raised to power minus 5. So can you calculate the ratio of acetate to acetic acid? How you will do this? pH is already given. So like one hint is that if you have the Ka value of acetic acid, then this is we are talking about acid in the solution, right? And this acid will dissociate between acetate ion and H plus ion, right? So the equation will be what? Acetate acid in the left hand side and acetate ion plus H plus ion in the right hand side. Okay, and if you has given the Ka means this is the equilibrium constant for the acid. So what you will have? Then this will be nothing but the multiplication of the concentration of product upon the concentration of the reactant, right? So so you will have, and the pH is already given. So pH matlab you have the concentration of H you can calculate from the pH, because if you will do the anti-log of pH value, then you will get the concentration of H plus ion. So if you have H plus ion concentration, if you have Ka, then the ratio you can get very easily. Is it? So let me show you. So as I told you, if the Ka value is given, so Ka means you have the acid, okay, and you first have to have that equation, and that equation will be acetic acid will dissociate between H plus ion and the acetate ions, okay, and we know that Ka, that is the equilibrium constant of acid, will be the concentration of H plus ion multiply the concentration of acetic acid upon acetate ion upon the concentration of acetic acid, and the Ka value is already given, and from pH value we can calculate the concentration of H plus ion if we will do the anti-log of this. Okay, so if we have the value of Ka, if we do have the value of H plus ion, then easily we can calculate the ratio of this acetate upon acetic acid. Is that clear? So this is how we can calculate the ratio of acetate to acetic acid. using the equilibrium constant for the acid. And the H plus ion, the concentration of H plus ion we can calculate from pH, because pH is nothing but the minus log of H plus concentration. And if we want to have the value of H plus concentration, then we will do the anti-log of the pH value. So this is how we can have the solution for this question. Is it clear? Very simple question. Should we go further? Okay, Sonia. Okay, the next question is very much similar to the assignment question 3, and this is, if we have a buffer solution and that buffer solution has two kind of two things. We have the base, that base is ammonia, weak base, and then the salt of its base, that is ammonium chloride. Okay, so we have two compound, that is the so we have ammonia and the concentration is 0.25, and then salt of this base, that is 0.15 molarity, and the pkb is already given for the salt, that is 4.75, and what you need to get is the pH of the buffer solution. So pH of the buffer solution means you need to have the concentration of H plus ion. And if you will do the minus log of H plus ion concentration, then you will get the pH. But how you will get it? Based on the information that has been given to you. For the buffer solution, we had some formulas. I should tell you. Uh, okay, Dilip Kumar, I understand that you have the poor internet connection. Okay, it's all right. So here we understood that if we do have the buffer solution, and for that buffer solution, pH can be calculated. If it is a base and it's salt, then the formula will be pH is equal to pKa plus log of the concentration of salt upon concentration of acid. Okay, but if it is a base and the salt of that base, then the formula will be pKOH is equal to pKb plus log of the concentration of salt upon concentration of base. So can you tell me here, like, what we will do? So very simple. We have the concentration of acid. We do not have, sorry, concentration of base. We have concentration of salt. We have, and then we also have pKb. Then this is very much simple. Then how we can calculate the pH? So how we can calculate? So we do know, like pK. Okay. Now here, you just have to see, we from this equation we have to calculate the POH. Okay, and then this POH is equal to pKb plus log of the concentration of salt upon concentration of base. Okay, and this is how you will calculate first the value of POH. And we know that like there is a relationship between pH and POH, that the addition of pH plus POH will give you the value 14. So if we will subtract the value of POH from 14, that will give you the pH. So there was nothing but you have to just fit in your values into one formula, and that will give you the pH of your buffer solution. Is it clear? Okay. Okay, the next question is, you have one solution that have the molarity 0.3 molarity, and this solution is of a weak monoprotic organic acid. So you have only, that will give you just one H plus ion, and and because this is weak organic acid, so that's why the ionization will be just 2%. Okay, and then you need to calculate the value of Ka. So Ka is nothing but the equilibrium constant for the acid. So how you can calculate this? How can you calculate the value of Ka? So the thing is, if we do have the ionization fraction, that is alpha, if this alpha is 2%, so it means the value is 0.202, and initial concentration was zero point 0.3 molarity. And there is a very simple formula, that is the equilibrium constant for acid is equal to alpha square multiplied by the concentration. And this is how this will give you the Ka value. So we had a ionization value, so it was 2%, that was 0.02, and then we have to multiply the square of alpha square with the concentration of your solution, and that was 0.3, and this is how this will give you the value of Ka. But the question is, from where this formula came? So I do have one slide for this. So for example, if you had one compound, that is one solution Ha, and it will be dissociated between H plus and A minus, and if you are having the acid dissociation constant Ka, this will be nothing but the product of the concentration of H plus ion and A minus ion upon Ha concentration. And because here we know that uh, here the acid will dissociate into equal amount of H plus and A minus. So here what we can do is okay, just keep in mind here. And if so, because this is the equilibrium means your solution here, sorry, your acid that you had, that is the Ha, this will be dissociate. Okay, so whenever it will be dissociated into H plus ion and A minus, it means your Ha concentration will reduce. Okay, and if the ionization is alpha, then the concentration of H plus will be alpha into concentration, and the concentration of A minus will be alpha into concentration. And the undissociated Ha will be nothing but you have to subtract this alpha C from concentration, total concentration. And if you are putting this value into the equilibrium constant for the acid, then you will get the same thing, the alpha square upon alpha square multiply by C. So from here you got the formula, and this is how you can solve this question. So whenever you have alpha square, that is the ionization in percentage, and then concentration, then you have to multiply this the alpha square upon multiply by the concentration, and this will give you the Ka value. So this is how you can calculate the and you can solve this question. Okay, this is the question. If you have aqueous solution of sodium acetate, okay, and in that solution a solution of iron chloride is added, the resulting solution will be what? Acidic, basic, pH will remain unchanged, or pH will be neutral? What do you think? What will happen? What do you think? What should be the answer for that? If you have two solution, and if you are mixing that two solution together, then that resulting solution will be either acid, base, or it will not change, or the pH will be neutral. What do you think? You just have to see whether the sodium acetate is acid or base, then iron chloride is acid and base, which one is stronger, Then based on that, you can tell like what will be the resulting solution. So can anybody suggest? Can anybody guess? Okay, so here the resulting solution will be acidic, and how it will be the acidic. So let me tell you. First, we have the solution of sodium acetate. Okay. Uh, yes, Dilip Kumar, this should be A. So how this should be A? Then first we have the solution sodium acetate. Okay, and that sodium acetate will be dissociate between acetate ions and the sodium ions. Okay, and then this acetate ion will be hydrolyzed by H2O, and this will give you the OH minus. Okay, so what you got is sodium acetate is giving you OH minus ions. So this is trying to give you the basic characteristic of the solution. But whenever you will add this iron chloride into the solution, you know that iron is a very strong Lewis acid, and this will give you H plus ion. Okay, and what will happen if H plus ion will increase over the time, then OH minus ion have to be decreased. Okay, and if OH minus concentration will be decreased, then automatically our pH will be decreased, and this will give you the acidic solution. So is there any problem with this? Initially, sodium acetate was giving you the basic solution because of the OH minus ions it was giving, but because of the iron chloride, this is giving you the higher H plus ion. So because of higher H plus ion, OH minus ions have to be reduced, have to be decreased, and based on that, this will give you the acidic nature. So this is how you will have the acidic nature of the this solution. Okay, this is very much simple question. Okay, and you need to calculate the pH of the solution when the molarity of the H2SO4 is 5 multiplied by 10 raised to power minus 4. Very simple. So you have the molarity of the solution, and then because pH is nothing but the minus log of the H plus concentration. है ना? So what we will do, we have to first calculate how many moles or how many H plus ions we are having from H2SO4, and we will multiply it with the molarity of uh, 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 the molarity of H2SO4, and then we will calculate the minus log of this. Then this is how we can calculate the pH of the solution. So if you people have the pen and paper, then you can calculate this. Okay, someone gave me, Linga Raju gave me the answer D, that is 3.3. This is 3. This is how I will tell you. Because here we are multiplying it with 2, actually. So that's why. So what we will do, first we have the concentration of H2SO4, but we know that each H2SO4 will dissociate and will give you the 2 moles of H plus ion. Right? So H plus ion concentration will be equal to the 2 multiply by the concentration of H2SO4. So this is how you calculated the value of H plus ion concentration. And this is now your job is done, because pH is nothing but the minus log of H plus ion. And if you will calculate it, then you will have the value of 3. Is there any problem with this question? This question was very simple. You just you have the molarity of sulfuric acid, then from that you just have to know like how many moles, how many H plus ion mole you will have from H2SO4, and then you will multiply with the molarity, and then you will have the concentration of H plus ion, you will do the minus log of it, and then you will have the uh, then you have the value of the pH. uh, some Nari Kantapa told me, no ma'am, I couldn't understand what you mean by this. No ma'am. You can tell me like why you wrote this. Should we go further? Okay. So the next question is, if you have you just need to calculate the pH of the buffer solution. We already have that formula of the buffer solution. And here, what we are doing, uh, we are mixing acid. The first is acid because we are having the hint. That hint is giving you the value of the equilibrium constant for the acid. Okay, so first you have acid and the second is salt of that acid. And the mass, the weight of that acid and the salt is given in 1 liter of water. Okay, and then you need to calculate the pH of buffer solution. So how you will calculate it? Can you guess how you will calculate this? We have one formula for this, right? Whenever we have acid, then based on that acid, we have the value of pKa. If we have the concentration of acid and if we do have the concentration of salt, then what we can do, we can calculate the pH value. So the thing is, we have the weight of this, we have the mass of the salt and the mass of the acid, but we have to calculate first the concentration. So if we do have the concentration of the molarity of acid and salt, then what we can do, we can calculate. So how you we in a very initial slide, I told you how we can calculate the molarity. So molarity was nothing but the given mass upon molar mass upon volume of the solution. So here volume of the solution is 1 liter and the given mass is 12. So 12 upon the molar mass of the acid upon 1 liter. This will give you the molarity of the acid. And in a same way, you can have the value of the concentration of salt, and this will be 30 upon the molar mass of that salt upon 1 liter. This is how you will have the molarity, or you can say the concentration of the salt. If you have concentration of salt, if you have concentration of acid, if you have the value of pKa, then you can easily calculate the value of pH. So this is how we can calculate. So first we calculated the molarity of the acid, and here the molar mass was 119 upon 98. And then we calculated the molarity of the salt, and this was 0.211 molarity. And then what we need to just do is, we do have the formula, and that formula is pH is equal to pKa plus log of the conjugate base. So conjugate base is nothing but the concentration of salt upon concentration of acid, and every value we already have. We just need to put the value into the formula, and this is how we can calculate the pH. So very simple. So this is how you can easily calculate and easily solve your assignment question 7. Just the value and the compound is different. Otherwise, the methodology will be same for solving that assignment question. Okay. So the next question is, you have to calculate the pH of buffer solution. Again, the buffer solution, you know the formula of the buffer solution. And here what they did is, they have given us the concentration, but that concentration is in mg per liter. But we know that our concentration is in mole per liter, right? So we have one acid. So this buffer is made up of acid and the salt of acid. Okay, so we have acetic acid and we have sodium acetate. But here the concentration is given in mg per liter. But we need the concentration in mole per liter. And then there is one more condition, is that then we are adding 15 mg per liter of KCl into that. And then what will be the pH of this buffer solution? So can you think like how we can calculate this? Again, the formula will be same, but there will be a few things that you have to keep in mind. The first thing is, first you will calculate the concentration into mole into liter, mole per liter. Okay. Then what will happen? Then because you are adding 15 mg per liter of HCl, then your volume will be changed. Okay. So first you will calculate the volume of HCl, and then you will add up all the volume, because that will be the total volume. Okay. And based on that total volume, the concentration of acetic acid and sodium acetate will also be changed. And then you will calculate the concentration of acetic and sodium acid again. And then you have to see how much H plus ion this HCl is giving to you. So based on that, you have to minus. So let me show you. So what you will do is, first you will convert your mg per liter to mole per liter. So for the acid, you will calculate this. For the base, you will calculate it. Uh, yes. So what you have to do is, you have the concentration in mg per liter, and if you are dividing it with the molar mass, then this will give you the mole per liter. Yes, obviously. So this is how you will get the acetic acid concentration and the sodium acetate concentration. Then what will have you do? Then again, then also calculate the molarity of HCl, and from HCl, because you know that the dissociation of this HCl will be near to completely, and this will give you the H plus ion. So whatever the concentration of HCl you will have, the concentration of H plus ion will be the same. Okay, so from HCl, you got the H plus ion concentration, right? Then we know the formula. pH is equal to pKa plus log of conjugate base. So you can call it as a salt upon acid. Okay, and before adding HCl, you had the concentration of acetic acid and your salt, and based on that, you got the pH 4.30. Okay, so this was before adding HCl. Then if you are adding the HCl, then what will happen to that? You have the H plus ion that will be added into that. Okay, so whatever the value of H plus ion we have added, so this will decrease the concentration of CH3COO minus by that concentration on only. So the new concentration of salt will be, you have to minus the H plus concentration, and the new concentration of acetic acid will be, you have to plus the H plus ion concentration from the original concentration of acetic acid, and this is how you will have two new concentration of your salt and acid, and again you will apply the formula, and this is how you will have the new pH after adding HCl. And obviously HCl is a very strong acid, so this will decrease your pH value. So I think this is clear. I know this was a little trickier, but I think you can understand. So the thing was, just need to convert from mg per liter to mole per liter. Then based on that, you can calculate the pH first before adding HCl. But from HCl, you will get to know how much H plus ion concentration the HCl is giving. Then you have to subtract and add the concentration of H plus ion from salt and acid, and based on that you will have the new concentration, and this new concentration will give you the new pH value. Is it clear? Okay. The next question is again very simple. You need to know the pH of the water sample where the OH minus concentration is 4.5 into 10 raised to power minus 5. So this is again very simple. We know that Kw is equal to 1 into 10 raised to power minus 14, right? And what was the Kw? Kw was nothing but the multiplication of the concentration of H plus ion and OH minus ions, right? So if we know the Kw value, if we know the OH minus concentration value, we can easily calculate the concentration of H plus ion. And if we know the H plus ion concentration, then pH is equal to nothing but the minus log of H plus ion. Or the second thing is, like you can also calculate it into by using different method, not different method but with the same method but in a different way. The different way is from so from OH concentration you can calculate POH, right? So POH will be nothing but the minus log of the concentration of OH minus, and you have given the OH minus concentration, right? So whenever you will have the POH, what you will do, and you know pH value will be so total value is 14. So whenever you will subtract this POH, then this will give you the pH. So see, no, this will give you 9.3, near to 9.3, and this is how, because you know that uh, H plus ion OH minus is 10 raised to power minus 14. Then from here you will calculate the H plus ion concentration, and H plus ion concentration will be 2.2 into 10 raised to power minus 10. And if you will do the minus log of this H plus ion concentration, this will give you near to 9.3. Okay, this is very simple. You just need to know is your Kw is 10 raised to power minus 14, and this Kw is nothing but the product of the concentration of H plus ion and OH minus. And if you have the OH minus concentration, then you will have the H plus ion concentration. You can easily calculate, and then you will do the minus log of this value, and this is how you can calculate the pH value. Okay. The next question is, if 20 ml of 0.2 molar HCl is diluted to 100 ml of solution, the approximate final solution is. So here, very simple. First, you have molarity of 0.2 of the HCl when the volume was 20 ml, but now the volume is 500 ml. So volume of 500 ml means your molarity, your concentration of HCl will be changed. Okay, so whatever the concentration of HCl you will have, and you know HCl is a very strong acid and it will completely dissociate into H plus ion and Cl minus. So whatever the concentration of whatever the molarity of HCl we will have, the same molarity value or same concentration value we have for the H plus ion also. And this is how, if we do have the value of H plus ion, then the minus log of H plus ion will give you the pH. So first we have to have the value of new molarity. And how we can calculate the new molarity value? Very initially we studied about this, that M1 V1 is equal to M2 V2, right? So yes, the answer is Tuma is also giving me right answer, that is 2.1. And this is how we can have so here normality is also equal to molarity, because the acidity is or the basicity is 1 only. So this is how we will calculate the new molarity, and after new molarity we just need to put that value of new molarity into minus log of that molarity, and this is how we will have the value of pH. Is it clear? Should we go further? So this is how you can solve your assignment question 10. But just keep in mind that I have changed the value and the compound name, but the strategy of solving the question will be same. Okay, Sonia and Ajay, let's move to the question number 11. So now we have the buffer solution, and that buffer solution is, again, the solution is made up of acid and the a salt of that acid. So acid was acetic acid, and the salt of acid is sodium acetate. And you have the concentration, that is n by 3, and n by 3 you have given the volume of this, and you also have the dissociate constant of acetic acid, that is uh, Ka is also given. And now you have to calculate the pH. So I think you can calculate it very easily, because pH is equal to pH is equal to what? This will be the log of Ka, and plus, you know this formula, right? I show you actually. So what you have to do is, uh first, you have the concentration, and that concentration is n by 3. So by n by 3 you just can calculate this. N by 3 is nothing but 0.33 mole per liter. Okay, so you have the concentration, initial concentration. Okay, then but because the volume will be changed, volume will be 150 plus 50, so your volume will be 200. So based on that value, the concentration of acetic acid and sodium acetate will be changed. So based on that, you will have new concentration value of acetic acid and sodium acetate. Okay, and you know that pKa is nothing but the minus log of pKa, and pKa is given. So that's how you can calculate the pKa, that is 4.74. And pH is equal to pKa plus log of salt upon acid concentration. And you have every value, and then you can put it, and you can have the value of this pH. So the thing was, because initially you had the concentration of acetic acid and the sodium acetate, but because you are mixing that solution together, so volume will be changed, and the concentration or molarity of acetic acid and sodium acetate will also be changed. Okay, and this is how, if you have calculated the concentration of new solution, that new volume solution, then the job is done, because you have to put all the values into the formula, and then you will have the answer for this. Okay, then yes, Chini and this has given me the right answer. Vanilla, they have told me like this is yes. Okay, this is question is very similar to the one question we already have done. So we have the solution molarity, that is 0.25, and we have the acid, that is monoprotic. That means it is giving you 1 mole of H plus ion. But because it is weak acid, then dissociation is not 100%. The dissociation is only 3%. And now you need to calculate the value of Ka. So can you calculate the value of Ka? Okay, again, I have answer A. Okay, here the answer will be B. I show you how. So the first thing is, the initial concentration of HA is equal to 0.25, and then the degree of ionization is 3%. 3% means 0.03, and we know that the formula of Ka is nothing but alpha square into the concentration. So alpha square was nothing but 0.03%, and we had the concentration that was 0.25, and this is how we have the value 2.25 into 10 raised to power minus 3. Just keep in mind the formula of Ka is equal to alpha square multiplied by the concentration. So this is how we can calculate the value of Ka. Is it clear? Okay, I think I will take 5 more minute, and then we will go for the, like, I have my dinner time right now, so we will go. Okay, the next question is, again we have the pH of the solution, that is 7.4, and again you need to know the ratio of bicarbonate to carbonic acid. If the dissociation constant of H2CO3 is 4.5 into 10 raised to power minus 7. So how you can calculate this? So the thing is, Because here it is not the buffer solution, right? Everyone is giving me the C answer and A answer. How you can calculate it so rapidly? What you people are doing? I'm not understanding it. But anyway, my slide is not visible to you, to everyone. One person told me that, ma'am, your slide presentation is not appearing and only host and visitor icon were in appearance. My slides are visible, right? Okay, visible. Okay, Sonia gave you the suggestion that they have to pin the slide. Okay. Thank you, Sonia. Uh, okay, so now thing is that if uh, so for the pH, if the pH is 7.4, from pH we can calculate the value of H plus concentration, right? And we know that this carbonic acid will dissociate between bicarbonate and H plus ion concentration, right? And if we have that dissociation, if we do have that equation, carbonic acid in the left hand side, and that will give you the bicarbonate plus H plus ion. So bicarbonate multiplied by the H plus ion concentration upon carbonic acid concentration will give you the Ka, and Ka is already given. So what we need to do is, and then if we will move this H plus ion concentration to the left hand side, to the Ka value, then this will give you the ratio. I show you. So from pH we can easily calculate the value of H plus ion, right? So we calculated the H plus ion concentration. We know that Ka is equal to nothing but the multiplication of the concentration of bicarbonate and H plus ion, and divide by the carbonic acid. And we do have the value of Ka, we do have the value of Ka, H plus ion, and this is how this will give you the ratio of bicarbonate to carbonic acid. Okay, so I think this is clear how we can calculate the ratio of bicarbonate to carbonic acid. Should we go further? Okay, because I do not have time, so I have to like do it fast. Then the thing is, we have to calculate the volume, and what volume of 0.2 molar sodium acetate solution should be added to 100 ml of 0.1 molar acetic acid to prepare a buffer solution with a pH of 4.76, and you have given the pK value, that is 4.76. So you need to calculate the volume. So how you will calculate the volume, I show you. So first you have the buffer equation, and in which you got to know that here the pH value and pKa value is equal to, like, is equal. Okay, so whenever they are equal, then what will happen? If pH is equal to pKa, then log of salt by acid will be 0. And if we will remove this log from the equation, then salt upon acid will be 1. Okay, and then what will happen? Because we are adding the solution, we are here the volume of acetic acid is 100 ml. Then what we will do, we will have the concentration of salt is zero point 0.2 into x, so the volume that we will add, okay, so 0.2 into x upon x plus 100. So this is the total volume that we will get of the salt. Sorry, this x plus 100 is equal to the total volume of the solution. Okay, and the salt concentration will be whatever the salt concentration we already had, and we have to multiply it with the volume that we need. Okay, and then the concentration of acid is, we already have this we already have 0.1 into 100, because 100 volume of acetic acid we already had, and then total volume will be same, x plus 100. And we already know that salt plus acid is equal to 1, and this is how we can calculate the value of x, and this will be 50 ml. I think this was little trickier, but once you have the slide, you can easily calculate, and you can easily understand this. I have three more questions. Up to 18, I had this question. So the next question is, if you are mixing two solution, if you are mixing H2SO4 solution with NaOH solution, what will be the pH of the resulting solution? So here you have to keep in mind, the H2SO4 is acidic in nature and NaOH is basic in nature. Okay, so H2SO4 will give you some H plus ion, and NaO2, that is basic in nature, will give you OH minus ion. So what will happen? Some of the H plus ion concentration will be neutralized by the OH minus concentration. Okay, and then whatever will be the remaining, that H plus ion will give you the resulting pH. Okay, so how we can do this? So first we have to calculate the moles of H2SO4, and that moles we can calculate by normality into volume, and this is 0.08 moles, and total equivalent we can calculate by multiply by 2, because each H2SO4 is giving you the 2 moles of H plus ion, and then you will calculate the mole of NaOH. So you will get the moles of NaOH is equal to 0.06. So just keep in mind, because here 2 mole of NaOH will neutralize 1 mole of H2SO4. So this is how you have to, for getting the value of H plus ion that will remain, you have to minus it. Okay, so you have to minus from 0.16 the value of 0.06, and this is how you will have the remaining H plus ion concentration. And if you have the remaining H plus ion concentration, if you have total volume, then you can have the H plus ion concentration, and based on that H plus ion concentration, you can calculate the pH. You just need to keep in mind, you have acid, you have base, and some of the H plus ion will be neutralized by the base. Then you have to subtract that H plus ions from the ions that will be taken up by the OH minus, and then whatever the remaining H plus ions you have, that will give you the pH value. So this is how you can calculate the pH value. This is again very similar. I don't think that I should go with this, because we already know that the alpha square multiply by the concentration will give you the dissociation constant, right? So this is very simple. Okay, this is, I'm just doing it very fast, just 1 minute or 1 minute. Okay, so you have now acidic buffer mixture, and you mixed it with the acid, that is Ha, and the salt of that acid, that is NaH, and the total molarity is given, that is 0.32 molarity. pH is also given 4.8, and the Ka is also given. And now you just need to tell the concentration of salt and acid. So you know the formula, right? You know this formula, pH is equal to pKa plus log of the concentration of salt and acid, and you need to calculate the concentration of salt and the concentration of acid. So every value is given. So what you will get, the salt and acid concentration you will get, and the total molarity is also given. So this is how you can calculate the concentration of salt and acid from this formula only. Okay, this is the last question. Here what you are doing, you are mixing two solution, and this solution volume is different, 25 ml and 75 ml, and the molarity of first compound is 0.1 and the second is 0.1, the same. And this is how you need to calculate the pH. So how you will calculate the pH? So for pH you need to calculate the H plus ion concentration, and how you will calculate the H plus ion concentration is you need to calculate the moles of HNO3, the moles that is given, the moles of H plus ion that is given by HNO3, the moles of H plus ion that is given by HNO3, the total moles you will add up, and then whenever you have the total moles, then you will divide it by the total volume, then this will give you the total H plus ion concentration, and again the minus log of H plus. So I think this is done from my side. This was some trickier questions, so let it be like this only, and thank you. So if you have any problem, then you can tell me. Initially I was very slow, so based on that I couldn't complete my whole slide very clearly, but I will try to keep this. If you have any problem and any